What's up, guys? This video is all about reviewing and demonstrating graphing constant velocities. Now, before we get into graphing, I want to point out that we will be using these position versus time graphs and these velocity versus time graphs. And we can assume that the position versus time graphs are meters per second, and the velocity time graphs are meters per second, and then the time is still seconds from here on out. So let's start with an example. Let's say we have this awesome pug here, and we will call him Pugnacious. And let's say that we have his position versus time graph represented here, and I want to draw the velocity versus time graph for Pugnacious. So let's get down to business. If I remember correctly, the slopes of my position versus time graph correlate to the velocity. So I'm going to want to find my slopes, and that will help me to determine where on the velocity time graph I draw my lines. So this first segment here looks of 1 meter per second. So that means that my velocity is 1 meter per second. So I'm going to draw a line, the velocity versus time graph of 1 meter per second, because it's a constant slope here, which is represented by a constant line on the velocity versus time graph. And if I look at my next segment, which is from 3 to 5 seconds, I have a slope of 3 meters per second because it goes up 3 over 1 or up 6 over 2. So I'm going to draw a line at the 3 on the velocity versus time graph. So for 2 seconds, I have a constant velocity of 3 meters per second. So I'm going to keep doing this for each segment. So this next segment, there's no slope. So where does that go? On the 0 of my velocity time graph. The next segment, it looks like now I have a negative slope. And it's a negative slope of negative 2 meters per second. So I'm going to go down into the negative region here of the negative velocities, and I should have a slope of negative 2 meters per second. Up here, I should have a constant negative 2 meters per second velocity, which just means it's going backwards. Next, last but not least, I have a slope of negative 1 meter per second, which correlates to a velocity of negative 1 meter per second down on my velocity time graph. So each of my slopes should correlate with where the lines are at on the velocity time graph. So how about we take a look at the right side of the screen, which we are given a velocity versus time graph, and I want to draw the position versus time graph. So in this case, we want to do the opposite of what we just did on the left side. So here we're going to actually figure out what our velocities are, and that will become the slope on our position versus time graph. Because our position versus time graph, the slope tells us the velocity. So what I do is I write down the velocities at each segment, just like this, because that helps me to really easily draw my slopes on my position versus time graph when I'm ready to do so. And it looks like I have my first velocity for the first 2 segments is 0 because it's on the 0 on the y-axis. And so I'm going to just choose to start at 5. This is because I know I have a negative slope coming up, so I'm going to want some space. So I'm going to choose to start at positive 5, but I'm not going to have a slope because my velocity is 0, so I should not have a slope. There we go. My next segment is negative 4 meters per second for 2 seconds. So I'm going to want to go down 4 over 1, down 4 over 1, which would represent a negative slope of negative 4. So it should look like this. The next segment, which will be purple again, is going to be negative 1 meter per second. So I'm still traveling backwards in the negative direction, and this is for 3 seconds, and my slope up here on the position time graph should be negative 1. So I go down 1 over 1, down 1 over 1, down 1 over 1. The next segment should be positive 2 meters per second as far as the velocity goes, so my slope should become just that, positive 2 meters per second. So I go up 2 over 1, up 2 over 1, and last but not least, for the last 2 seconds I have a velocity of 3 meters per second, again positive, so now I should have a slope of 3 meters per second up on the position time graph. Up 3 over 1, up 3 over 1. Or if you look at the whole segment, up 6 over 2, which would also give us a slope of 3 meters per second. And you always want to check yourself. I'll just redraw my slopes up here, which should match the numbers on the velocity time graph. And they all match up, so it looks like we did it right. So let's take a break from me talking and let's give you a quick problem to check your understanding so far. Which of these two velocity versus time graphs, A or B, best correlates to the position time graph given above? Pause the video and try to figure out which one has the mistake, and then you'll be able to tell which one is correct. Ready, set, go! If you said A, you are correct. Great job. So where's the mistake in B? Well, a common mistake here is to start the position time graph at the same place as the velocity time graph, but it doesn't work that way. So we know that the slope of the velocity time graph, the slope of the position time graph tells us the velocity. So since there's no slope here, there should be no velocity, but B shows a velocity of -2 to start with. So A is the correct one. It has a velocity of 0, then a +1, then 0, and then -1. So great job finding that mistake. Now let's do our one last example page, and I want you to try it on your own. So here you're given a position time graph, and I want you to draw the velocity time graph that would correlate with that same motion. And then on the right side, you're given a velocity time graph, and I want you to draw the position time graph that correlates to that motion. And just to keep it consistent with my answer, start at position -2, which would be right here, because we're just assuming all of these units are going by 1. So pause the video and try to sketch those graphs, and then you can play it again to check the answer. All right, let's go ahead and check those answers. So this is what you should have gotten. You don't have to have all the numbers, but we're just looking at the shapes here. But as you can see, I drew the slopes because that's how I knew where to draw the velocity on the velocity time graphs. And over here, I started with drawing the velocity because that helped me to draw the correct slopes above on the position time graph. So check this carefully to make sure you have the same answers as I do, and if you got it right, great job. And that concludes our video, so thank you guys so much for watching. Have a great day.